Hi students, 5.2 of inverse circular functions, and quite a quick one. So first things first, try and fill the gaps, pause the video and fill in the 6 spaces. Off you go. Okay, so the idea of that was that it takes us back to this idea of anti-differentiation just being differentiation backwards. It's as simple as that. So if we have known rules for differentiating inverse circular functions, then we can use those rules to come up with some for integration or anti-differentiation. So just looking at the bottom of that page there, where are we? Should have set up my camera. The first one, well, using our previous results, this must be sine inverse of x over a plus c. For a result which gives us cos inverse, well, the domain of that is going to be exactly the same, because the range of cos inverse is the same as the range of sine inverse. And we remember the slightly tricky one, we don't have the square root, and we have a on top. And that gives us the rule for tan inverse. Just a little bit of an aside here. I want us to explore this idea of sine inverse plus cos inverse, because I'm sure you've noticed that these results are the same, but just one's positive and one's negative. So if I've got a function which is sine inverse plus cos inverse, that makes the derivative of that, f dash of x, equal to 1 over root a squared minus x squared, plus minus 1 over root a squared minus x squared, which is obviously 0. So the gradient of this function is 0, which means that the function is a constant, because the slope is 0. It does not increasing, it's not decreasing, it's always the same. And we could substitute in for 0. Sine inverse of 0 is 0, cos inverse of 0 is pi over 2. And that actually tells us the constant, so f of x is pi over 2 for all values of x in the range. So this is a really helpful idea, a little trick, and the kind of thing that's going to come up pretty often in the odd question. So a good thing to point out. I paused here because we need to think about, what's the range of sine inverse and cos inverse, and might get this wrong off the top of my head. But because we need the domain, we need the function, both of those parts to be defined. So that's going to be between 0 and 1. I'll check that and maybe we'll come back to that. First questions then. Using these principles, I want you to have a go at answering these questions, and then I'm just going to help you with the first one because I'm just going to show you a trick for notation. With any antiderivative or integral question, it can be quite helpful just to introduce a letter I which stands for that integral, because then later on I can just refer back to that I don't need to keep writing the integral all the time. So for each of these, define what your integral is, and then you can just say I equals, and then try these 3 questions. Give yourself a few minutes and then restart the video. Okay, so you've had a go at these and I'll run through them as well. With the first one, well, that a equals 3. So as I do this, there's really nothing else that's complicated about this. So the integral I is sine inverse of x over 3 plus c. We always need to remember the plus c. For part B, the integral is 1 over root 9 minus 4x squared dx. And then what I'm going to do is just start to adapt this a little bit so that my form matches the one that I've got up here. So the problem is the 4x squared. So what I'm going to do is bring a 2 outside of that square root. Sorry, this is not the best. This says 3 over 2 squared minus x squared. So you can have a look at this, but because I basically divided both these terms by 4, and then because I brought the 4 outside the square root, it becomes 2. So if I bring this 2 back inside the square root, that's going to involve multiplying both terms by 4, and I'm going to get the same result that I had here. So you could have a think about this yourself, but this is correct. And this form then gives us this, a half of this integral, bringing the 1 over 2 outside the integral. And in this situation, well, it matches the form for sine inverse exactly. It's got to be exact, with a equals 3 over 2. So I, the integral, must be a half times sine inverse of x divided by 3 over 2. So that's just 2x over 3. Always, always plus c. The last one is a very similar idea, but just one extra level of complication. So we've got our 1 over 9 plus 4x squared dx. Just like before, we take this 4 as a factor out, and there's no square root this time, so we don't have to square root it to get 2. It just stays as it is. And I've left this now as 1 over 4 times 3 over 2 squared plus x squared, or in other words, a quarter times 1 over 3 over 2 squared plus x squared dx. But this doesn't match the form for tan inverse yet, because we've got this pesky a that's on the numerator. So what we need to do is we need to fix that with the constant as well. So I need to get a 3 over 2 on top, which is going to mean, to compensate for that, I need to balance it with a times by 2/3. So I'm obviously not trying to change the value of this expression at all. So it has to be the same. And because I've multiplied by 3 over 2, I also need to multiply by 2 over 3, so it cancels. So what's going on here? Well, I've got a sixth, because that's a quarter times 2/3, times by this integral, and this integral now matches this exactly. So it's a sixth times tan inverse of 2x over 3 plus c. And that's our result. So that's the skill for today, and you're going to get loads of practice of it, but I want you just to, before you go on to the exercise, show me you've got that by translating this into definite integrals. These two, a and b, will give you an exact answer, whereas part c, you're going to have to use, you're going to evaluate it and then just use your calculator at the end to get a decimal approximation. So pause the video and try them. Use exactly the skills I just shown you. There's nothing new. And if you've got that, then we're done for today. So have a go. All right, you tried them. So I'll try and be quick. For the first one, we've got the integral from 1 to 0 of 1 over square root of 4 minus x squared dx. And this matches the form exactly that I'm looking for. So this is the sine inverse of x over 2 evaluated between 1 and 0. So we use our square brackets with 1 and 0 on the right hand side. That's our notation. So substituting in, that's sine inverse of a half, substituting in 1, take away sine inverse of 0. So sine inverse of 0 is 0, but sine inverse of a half is pi over 6. And that's one of our known values. sine of pi over 6 is a half, so sine inverse of a half is pi over 6. Job done. For part B, our integral this time is evaluated between 2 and 0, and it's 1 over 4 plus x squared dx. It's a tan example because I don't have the square root, and the problem is I don't have the a on the numerator. A is 2, right? Because this is the same as 1 over 2 squared plus x squared dx. So if I'm going to times by 2, I also need to divide by 2 so it balances. So this is the same as this integral. This integral is tan inverse of x over 2, exactly, evaluated between 2 and 0, which means if I do that, my answer is going to be a half of tan inverse of 1, substituting in 2, take away tan inverse of 0. Tan inverse of 1 is pi over 4. Tan inverse of 0 is 0, so my answer is a half times pi over 4, which is pi over 8. And well done if you got that. Part C, just ever so slightly more complicated. My integral between 1 and 0 of 3 over root 9 minus 4 x squared dx. I bring the 3 out of the front straight away, shouldn't be there, and I also bring a 2 out, and I represent this as 3 over 2 squared. Take away x all squared. This now matches my form exactly, so I have 3 over 2 from the constants here, times sine inverse of x divided by 3 over 2, so that's 2x over 3, evaluated between 1 and 0. So my answer is going to be 3 over 2 times sine inverse of 2/3 minus sine inverse of 0. The sine inverse of 0 disappears because that is 0 itself, leaving me with 3 over 2 sine inverse of 2 over 3. I can't simplify this anymore using my known values, so the only thing I'm left with is a calculator. If it's a non-calculator paper, I leave it like this, but if I plug it into my calculator, I get 1.095 to 3 decimal places. Okay, there we are. So, a super swift video today, 12 minutes only. Usual deal. Fill out the exit ticket, let me know if there's anything you've struggled with. Best of luck.